For a moment, imagine temperature. How hot can things get? The sun's core reaches millions of degrees. Some stars burn even hotter, billions of degrees. It seems like heat has no limit. But what about cold? Can things get colder and colder forever? Surprisingly, the answer is no. There is a limit to how cold something can be. Scientists call it absolute zero. Absolute zero is 273.15 degrees Celsius, the coldest temperature possible in the universe. But why does this limit exist? The answer is hidden inside atoms. Everything around us is made of tiny particles called atoms. These atoms are always moving, vibrating, and bouncing around. When something is hot, its atoms move very fast. When something is cold, the atoms move slower. Cooling something means removing energy from it. The less energy it has, the slower the atoms move. But atoms cannot move slower than completely stopping. That point, where motion reaches its lowest possible level, is absolute zero. But here is the strange part. Even at absolute zero, atoms don't completely stop. According to quantum physics, particles must always have a tiny amount of motion. This is called zero-point energy. Scientists have cooled atoms extremely close to absolute zero, just billionths of a degree above it. At those temperatures, matter begins to behave in strange and fascinating ways. Liquids can flow with zero friction, a phenomenon called superfluidity. Some metals lose all electrical resistance and become superconductors, allowing electricity to flow forever. And gases can transform into a strange new state of matter known as a Bose-Einstein condensate, where thousands of atoms behave like one single quantum object. But there is one thing scientists can never do. They can get very close to absolute zero, but they can never actually reach it, because the laws of thermodynamics say that removing the final bit of energy is impossible. So while heat may rise endlessly, cold has a final boundary, and that boundary reveals the mysterious quantum nature of our universe.